So the next topic we're going to talk about is mechanics, which is just the rules by which everything moves. And this is one of the most foundational elements of modern physics, in fact. Before that, people thought that everything had its own rules. And after the laws of mechanics were discovered, people realized that everything in the entire universe seemed to follow the same rules. Rather than rocks being different to planets or stars, it was realized that they actually follow the same universal principles. Now, if everything follows the same physical principles, then you'd imagine that we'd be able to figure out what they were fairly quickly, because everything would be reasonably simple. So why did it take literally thousands of years to figure out the laws of mechanics? Well, there's two main reasons. The first is that a rock and a waterfall and a feather and a fire and a star all behave extremely differently. And the main reason for that is that even though they follow the same rules, they're composed of very different things, and they have very different environments, which means that when they follow those rules, they do very different things. And the second is, the underlying rules are quite different to the apparent behavior of all the things we see around us. For almost 2,000 years, the dominant ideas of how things move came from Aristotle. And he described two kinds of motion. He described natural motion and violent motion. Now, the natural motion of something was what it would do if it was left to its own devices. And there were 5 kinds of things in the universe, according to the Aristotelian point of view. So the idea was that everything below the moon was made up of the 4 elements earth, air, fire, and water. And they all had a natural motion that was at rest, just still, and on the ground. So the earth would be in the bottom, then the water, then fire, then air. And the idea was that the ether made up everything that was in the night sky. So stars, planets, the sun, all those kinds of things. And then natural motion was to move and stay in the sky. And then violent motion was everything that you would do to make something behave against its natural motion. So for example, if you throw a rock, which is mainly made of earth, the natural motion is for it to be at rest and on the ground, and you have to apply some force to it in order to make it move. Now, I don't want to go into enormous detail about Aristotelian physics, because all of it is wrong. But it doesn't look so wrong at first glance. So for example, it's hard to know whether things are made up of earth, air, fire, and water, or atoms, because we haven't seen either of those things. And it's hard to know whether things way up in the night sky are made of something else, because we haven't been there. And also, this idea of things having a natural motion at rest and on the ground, that's incredibly intuitive. It's intuitive because all the things I see when I look out my window are at rest and on the ground, with the possible exception of a fountain of water, and that water is dripping down because it was pumped up there. So someone imparted some violent motion to get it up there, and then pretty shortly afterwards it's at rest and down in that pool. Look around the room now, you probably see a large number of objects, and they're probably at rest and sitting on things or on the ground. And so in other words, this is a very strong intuition that we have, that is normal. And so all of this was so convincing and reasonable sounding that over the next 1,000 years it became accepted knowledge. People were taught it, educated people were taught it, would teach other people. It became Christian church dogma. And really over the next 1,000 years, the only things that happened was that various people worked on trying to improve the details of this idea of violent motion. So if you pick up a brick and you throw it, once you've given it that force, you can make it move and make it not be on the ground. But once you let go, why does it keep moving for a while? Why doesn't it just stop and be on the ground at the same time suddenly? And how do you get through the details of that? And people invented ideas of things called impetus, which is the set of ideas that try and describe from an Aristotelian point of view how something that's been thrown keeps moving even once you let go of it. And this was invented by a Greek philosopher and then refined over centuries by Persian philosophers and then finally by Western philosophers.